Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving equations. So an equation is something like this. You can tell it's an equation because it has the equal sign. So in equations, we're going to look at when they have one pronumeral, one letter, and we're going to try and solve the equations. What does it mean to solve an equation? It just means find a solution. When we're solving an equation like this, we want to find the number that we can substitute for the pronumeral to make this a true statement. So it turns out in this one, the solution would be x equals 6. Why would it be 6? So if I take my equation, 5x minus 7 equals 23, and I substitute x for 6, I end up with this. This is a true statement. 5 times 6 minus 7 does equal 23. So when I substitute x equals 6, I get a true statement. That's how I know it's the solution. It's the only solution. If I substitute any other number, like x equals 4, I would not get a true statement. If I take my equation 5x minus 7 equals 23, and I substitute x for 4, I get a false statement. 5 times 4 minus 7 equals 23 is a false statement. So x equals 4 is not the solution. In all the equations we are solving, there will only be one solution. One number you can substitute for the pronumeral, the letter, to make it a true statement. So how do we actually come up with a solution like this? Well, what you do is you undo what's been done to the pronumeral in the opposite order to BIDMAS. And this part here is crucial. If you do things in the wrong order, you will get the wrong answer. So think of it like this. In the morning when you're getting ready for school, you put your socks on and then your shoes. At night, when you get undressed, you take off your shoes first because they were the last thing you put on. So the last thing you put on is the first thing you take off. And so it is with equations like this. 3x plus 1 equals 13. What we've done to x is we've multiplied it by 3, then added 1 to get 13. So when I'm solving, because adding 1 is the last thing I did to x, it's the first thing I undo. So I undo by subtracting 1 from each side. And when you're solving equations, you have to remember this rule. What you do to one side of the equation, you must do to the other. That's to keep them in balance. So plus 1 and minus 1 cancel each other out. So I'm just left with 3x equals, now 13 minus 1 is 12. So remember, 3x means 3 times x. The way we undo timesing by 3 is dividing by 3. So then we're left with x equals 4. That is our solution. Why is that the solution? How do I know I'm right? Because if I substitute x for 4, I get a true statement. 3 times 4 plus 1 equals 13. That's true. So let's try this one here. People always get mixed up with these kind of equations. They're always like, what do I do first? Well, here, the pronumeral's y. Because of BIDMAS, I do multiplication first. So y has been multiplied not by 5, but by negative 5 first. And then we've added 18. This 18 here is a positive. So just like the shoes and socks, because adding 18 is the last thing I did, the last thing I put on, it's the first thing I take off. So I'm going to subtract 18 from both sides. 18 minus 18 is just 0. They cancel each other out. So on the right-hand side, I'm left with 15. 33 minus 18 is 15. But over on this left-hand side, I'm left with minus 5y, negative 5y, not positive 5y. So now I need to undo timesing by negative 5. I'm not going to divide each side by positive 5. I need to divide by negative 5. The only way you can undo timesing by negative 5 is to divide negative 5. So then I'm left with y equals 15 divide negative 5. Remember, positive divided by a negative is a negative. So y is negative 3. If I substitute y for negative 3 into this, I would get a true statement. All right, let's look at some equations with brackets. So when you have equations with brackets, there are two things you can do. You can either expand the brackets or first divide. I'll show you both ways. So if I'm going to expand these brackets, remember distributive law, I go 8 times x, and then I go 8 times positive 3. So that will give me plus 24. And I've got 8x plus 24 equals 16. And I solve this the exact same way I did on the previous slide. What I'm going to do is subtract 24 from both sides and then divide each side by 8. So the other way I could have done this, I could have simply divided by 8. Here what I've done to x is I've added 3 first, then multiplied by 8. Because this was the last thing I did, it's the first thing I undo. So if I divide this side here by 8, I'm just left with x plus 3. If I divide 16 by 8, I get 2. Remember, what you do to one side of the equation, you must do to the other. Because I divided this side by 8, I must divide this by 8. So I'm left with x plus 3 equals 2. Subtracting 3 from both sides, I get x equals minus 1. Same answer from either method. All right, let's look at this one here. So firstly, expanding the brackets. 9 times 7, 9 times negative x, so positive times a negative is a negative. So now I'm going to solve. This is like the second example I did on the previous slide. Here I've timesed x by negative 9, then added 63. This 63 here is positive. So the way I'm going to get rid of it is by subtracting 63 from both sides because they cancel out. So then I would be left with minus 9x. 90 minus 63 is 27, positive 27. Divide by negative 9. My answer is x equals negative 3. Alternatively, I could divide first. So here, I have times x by negative 1, then added 7, then multiplied by 9. So if I divide each side here by 9, what you do to one side, you must do to the other, I would be left with 7 minus x equals 10. Subtract 7 from both sides. This is a positive 7, so the way I'm going to get rid of it is subtracting. So I get minus x, negative x equals 3. If negative x equals 3, then positive x must be negative 3. I've gone from here to here by changing the sign of each side of the equation. You can do whatever you want to one side of the equation, like changing the sign, as long as you do the same thing to the other side of the equation. So notice I got the same answer from both methods. Either one you want to use is fine. So again, this is the solution, the only solution, because if I substitute x for negative 3 here, I would get a true statement. I get 9 times 10 equals 90, which is true. All right, let's look at some equations with fractions. So when you've got equations like these with fractions, remember the fraction line means divide, and the way we undo division is multiplying. So these equations, hopefully they look to you to be very similar. The only thing different about these two equations is the order of operations. Here, we subtracted 8 from x first. Here we divided x by 5 first. Now, because these two have slightly different order of operations, the answers will be totally different. So that's why it's so important when you're solving, you do things in the opposite order to BIDMAS. If you get the order of operations incorrect, unfortunately, that will give you the wrong answer. So in this one here, we subtracted 8 first, then divided by 5. Dividing 5 is the last thing we did, so it's the first thing we undo. Now, when you're multiplying a fraction like this by 5, don't multiply the top. The whole reason we multiply by 5 is to undo dividing by 5. Dividing 5 and timesing 5 undo each other. We're just left with x minus 8, so don't times the x or the 8 by 5. On the right-hand side, we just have 3 times 5, which is 15. Okay, so x minus 8 equals 15. This is an easy one to solve. We undo subtracting 8 by adding 8 to each side. And that gives us the answer x equals 23. That is the solution, because if I substitute x for 23 into this equation, I get a true statement. All right, so this one over here, we're going to do it similarly, but the order is going to be different and we'll get a different answer. So here we've taken some unknown number x, divided by 5, then subtracted 8 to get 3. So because in this one, subtracting 8 is the last thing we did, it is the very first thing we will undo. So don't try and add 8 to this term here. X over 5 and 8 are not like terms. They can't be added together. The whole reason we added the 8 was to get rid of subtracting 8. These two cancel each other out. So on the left-hand side, I'm left with x over 5. On the right-hand side, 3 plus 8 is 11. Okay, so as I said, fraction line means divide. This means x divided by 5 equals 11. So how do we undo dividing by 5? Of course, we times by 5. So remembering the point I made over here in this step, when we're timesing by 5, we're not going to times this and make it a 5x. The whole reason we're timesing by 5 is because that undoes dividing by 5. They undo each other. So I'm left with x equals 11 times 5, which is 55. Once again, this is the solution. If I substitute into this equation, I will get a true statement. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.